Why not watching the videos? Huh? Rishikesh, roll number 8, and Roshan, Roshan and Rishikesh. They are here or not?
Sir, I don't know the drive link, and I was not there in last week and this week also in lectures.
So it does not matter you are there or not, but it was the videos which are uploaded for the last, I think, I don't know, 2 months ago.
I
Are you
don't
restricted?
remember. So
So don't
I will
attend the
see.
today also don't attend the lecture then.
Sorry, sir.
See, yeah, we are not here to do time pass. No, मैं यहाँ पे upload करते बैठा हूँ पागल type का, and you're not watching the videos. So, anybody has got doubt in those videos? Ah, yes, Nikita.
Yes.
कुछ doubts? Have you got any doubt?
No, sir, because I watch only the 2 to 3 videos.
Okay, but
In
have
that,
you
knowing that.
watched that video of unit number 3?
Yes, sir.
So till what day means I should ask the question that have you watched all the videos? It is like no, you can just make it fast to watch that video. The complete 1 hour video, it is not able to watch all the 1 hour video or something first, and you can see the videos where, because most of many times I've not talked on the topics, right? Sometimes attending, sometimes something. Unit test is going to come now. Watch the videos. I'm repeating it again and again. Otherwise, you will just going to have the problems, right? You cannot watch these videos in one day go. It's not possible. Make your notes, do some exercise.
So I didn't understand the conceptual relationship in the PPT.
What conceptual relationship?
सर PPT जो आपने दिया 3rd यूनिट का उसमें conceptual relationship है.
There was a random process. Unit number 3 or unit number 3 prerequisite?
3.
So I have not come to that point. I will just explain that if it will come, right? Okay. So what we will do today is I'm going to solve some numerical and just try to understand what are the steps that I'm following. If you don't understand the points at any point, you just ask me the doubts, right? So don't hesitate to ask the question because this is 2 hour sessions. So it should not be like I'm just talking, right? So ask the doubts if you have. But I feel like you have watched the videos, and based on that only I'm going to start here, right? So unless you don't understand those videos, it's not the it will be something what you have to what mug up all those things otherwise, correct? So let me start with this. So this is still the unit, not the unit number 3, but it's very much related to unit number 3 because I'm going to slowly move to the unit number 3 numericals, but I'm trying to solve some of the numericals on this prerequisite, right? First, so what is this is just what we are thinking of. We have only just mute yourself. Somebody is unmuted. Mute yourself. Right? आयुष आयुष से ही आवाज आ रही लग रहा है.
सर प्रणव बोर का है.
ओके, लोग बीच बीच में आते हैं, डिस्टर्ब करते हैं. ओके, so we are thinking only one random variable, right? Not two random variables. So we have only one experiment, and in that experiment I am just defining one random variable, and for that one random variable what the analysis I can do. So these are called as statistical analysis, right? So I am asking you to just remember one formula. This I have already given in that videos also. So if you go with that prerequisite video, you will see find this formula over there. So g of x is just a function of one random variable x, right? So g of x is a function. G of x is a function. So function of random variable is again going to be a random variable. So that is first thing. Function of random variable, it's going to be another random variable. So function, if you take some function of random variable, right? Let's say this is, I'm noting by g capital X of random variable x is another random variable. So what I'm saying is y is a random variable which is a function of random variable capital X. So y is a function of g of x. So if you see this y, in general what you can say 100% time this PDF of y is not equal to PDF of x, right? So these PDFs will be different. So this is y which is operating on x, and y is going to have its own PDF and x is going to have its own PDF. So fyy is not same as fxx. That is the first thing. Okay, but whatever it is, but if it is a function of x, then the expectation is also called as average of this g of x can be written as in this formula, right? This formula I've written it so many times, so you just remember this one formula. How to write this? Expectation of gx is nothing but minus infinity to plus infinity g of small x fxx dx. So this is the formula to calculate the expectation of any function of x, right? That is what average of any function of x. This is how you can find it out, right? So let's take some g of x value. So let me take g of x same as x, right? G of x same as x. So in
हेलो
that
सर.
case, yes,
सर आपका ईयरफोन का बहुत नॉइज आ रहा है.
okay. Everybody is getting that noise, or he is particularly getting that noise?
Even we are getting the noise.
Okay. Now is it? Now is it okay?
सब ज्यादा आ रही है.
Hello. Now hear my voice properly. Just remove that cable, that charging cable. Is it okay now?
Yes, sir.
Yes.
Okay.
Yes sir.
Okay. So fine. So what I'm taking is x, g of x is equal to exactly x. So no function you can say. It's just a one-to-one function and same function. So g of x is equal to x. So this formula becomes what? Expectation of x, that will be minus infinity to plus infinity, and this will be g of small x. So this will be small x and fx x dx. So this is capital X. So this is PDF of random variable capital X when capital X takes the value of small numerical value. This is the formula for that. Now let me take some more g of x. Just delete it first, then right. Next, let me take as the g of x as x square. So we have capital X square, and in that case the formula will be minus infinity to plus infinity x square fx x dx. Any doubt in this? This formula is very simple to find out this if you know this formula. And next I'm just taking what? X minus expectation of x, and I am making it square of this. right? So what I'm doing, I am taking this random variable x and subtracting the mean value. Mean value is called as DC value, right? It's the expectation of x, and I'm squaring it. So the formula becomes what? Expectation of x minus expectation of x square of this. So this can be written as what? Minus infinity to plus infinity. Now is g of small x, so this will be x minus. Okay, let me write some short notation for this. This is also known as mu x. Sometimes people call it mx, right? So let me write, this is just a number, it's a mu x, it's a mu x, right? So let me write that mu x, and this will be fx x dx, right? So this is what the definition that is how it goes. This is x square fx x dx, right? Now they have given the name to this integration. So we have name, and what the name is, क्या बोलते हैं इसको अपन, what we call it, what we call this expectation of x? Mean, right? So this is the mean value. People call it expectation, or I don't have to write this expectation, let's just write mean. I can call it average, or I can call it DC. So these are the DC values, right? So these are what? This is called DC value. Fine. So this is DC value. What we call it? What the name for this? Expectation of x square. What we call it?
Mean square.
Mean square value. So this is just mean square value. As a communication engineer, we are going to call it total power. You can call it total average power or mean square value, right? So the name is like this. And if you go with this, what do you call it? This thing?
Variance.
Variance. So this is called variance, but we want to call it AC power. And the short notation is what? Sigma x square, right? So these are the formulas, three formulas which are most widely used in our communication. But it's not like that there are only three formulas. You have more than, because you can have more than one. I think you can have infinite function of x, right? So there will be infinite averages. So this is called AC power. Why I'm calling AC power? What you are doing here? You are taking the random variable and you are subtracting the DC value. So the remaining portion is just the AC component. And when you square it, you get the total power. So if you see the unit of this, it's just a volt square, because you are squaring the value. So that's why it's volt square. Or if you have 1 ohm resistance, so you can call it 1 watt normalized power, right? So we may call it 1 watt or volt square, both are correct. But if you say 1 watt, it means you are assuming the resistance is 1 ohm. Again, the AC power is going to be again the square of the value, the square of this value. So we are going to call it again volt square, the unit is, or you may call it 1 normalized watt if 1 ohm resistance is there. Now if you see this DC value, it's just a volt, it's not a volt square, right? So how to get the DC power? How to get the DC power? It's very straightforward. If you have a DC value, right, so that then how you can find the DC power? DC power can be found by just doing what? DC value, you have to make it square of this to get the DC power. This is as simple as that. So then it becomes also in the unit of volt square. Or if you want to say this is 1 watt, if you are not 1 watt but just watt, and what I'm saying is 1 watt. This is watt. This is not 1 watt, right? It's watt. If I have 1 ohm resistance, and this is what in terms of volt square. So you get the expectation of x and you square it, you get dc power. So you may call it expectation of x square, right? So this is same notation. So this is for dc power, it's a total power and it's a ac power. So what you find the relation is, as we know all, that you can prove this also, right? That total power must be equal to the dc power plus ac power. So I can say this expectation of x square must be equal to the expectation of x square plus expectation of x minus mu x square, right? This is the mean square value, right? Don't get confused. Mean square value is what? You first square and then you find that mean. Here it's a square of mean, so sometimes people get confused over there. This is what square of mean, and this is what is this? This is mean of what? This is mean of square. You first square the random variable, then you find the mean. Here you are first finding the mean, then squaring it. So this is square of mean. So this is called DC power, this is called total power or mean square value, and this is the AC power, right? So this relationship is very useful because in numerical, if you get the question like find the DC power, AC power and total power, then you just need to find two powers. One is the AC power, one is the DC power, and then you can find total power by using this relationship. You don't have to find this expectation of x square. So in very simple thing, if I ask you how many statistical averages are possible, what is the answer? So how many statistical averages are possible to define? What is the answer? Yes. These are called statistical averages. So this all three are statistical averages. So there is example of statistical averages. Can you tell me how many averages, such averages I will have? How many? How many possible statistical averages are possible? Yes. Sorry?
So what do you mean by how many?
How many?
मतलब आपने ही बोला ना सर ये 3 है.
These are examples I said. If you take gx equal to x, this is one statistical average. If you take gx equal to x square, this is a statistical average. If you take gx equal to this is also one of the statistical averages. These are the averages, no? So how many averages are
Infinitely,
possible?
sir.
Infinite. Right? So there are infinite possible averages are there. Infinite. It's very simple to think because you can have any infinite number of function defined on one random.
में सर
Yes.
सर वो आप रिमूव फॉर मीटिंग का ऑप्शन बंद कर सकते हैं सर? कोई तो मीटिंग से निकाल दिया था अभी मुझे.
Yes, just wait a minute. So there are infinite number of functions are possible. Disturb mat kariye na. I don't feel I don't like this kind of things, right? यहाँ पे serious talk चल रहा है and अब you are disturbing everybody. तो मैं पूरी क्लास सस्पेंड कर देता हूँ. Right. So there are infinite number of possible functions. So I will have infinite number of averages I can define by using the same formula. I don't have to define. I will get. I can use the same formula and I can get that one. You can, if you want to see that one, you can take any expectation of g of x. Let's say, suppose take g of x as let's say sine of x, right? You will get expectation of g of x. Can write the formula for this? This will be minus infinity plus infinity. Then is g of small x, so this will be sine of small x, and then fx x dx. So there are n numbers of g of x you can define. So there will be n number of expectations are possible. So there are n infinite number of what averages are possible. I hope this makes sense. Now let's solve this problem. You can find the answer. What is the problem? You just read it and try to find the answer to this question. So we need to find mean square value and variance of random variable x whose PDF is uniform over the range -2 to +2, right? How will you find this? The very first thing is what? To use this formula. To use this formula, you need to find fxx. So the question should have given the formula of fxx, then only you can apply this formula. So the very first task is to create PDF or to write the expression for PDF. So in this formula, it's written in this question, it's written what? The PDF is uniform over the range -2 to 2. When you say term uniform means what? The probability of values between -2 to 2, it's same, right? Means this is random variable whose value can be between -2 and 2, and all the values between -2 and 2, they have the same probability. That's why you're calling it what? Uniform random variable. So if you say me that what is uniform random variable, so I will draw what? PDF, right? So PDF कैसे draw करना है? Let me draw that. So the PDF will be like so this is uniform right. So I'm just drawing what? PDF. I can draw it, I can write it. So this is x, and it is from -2 to 2. The range is -2 to 2. So before this it's 0. After this the PDF is 0. But between -2 to 2, all the values are equiprobable. This is the distribution of the values between -2 to 2, which is uniform, which is saying me this is uniform. Anybody is having any problem in this? Yes.
No, sir.
Okay, so the very first thing is what? You got this PDF diagram, but the question is, what is the height, right? What is the height? That is the problem, that I need to understand that how to find the height first. So I need to find this height that is unknown to me. How to find the height first? So we know that one. I know that that the values are only between -2 to 2. Hence, the area under PDF has to be 1, because this is what the property it has to be there, because when you find the total area under the PDF, the probability has to be 1. So the total area under the PDF must be 1. That is the property I'm going to use to find out height. So how to find
H equal to 1/4.
height is just what? You need to use the property that total area under PDF must be 1, because probability, the maximum probability has to be 1, so the area has to be 1. So it's a fairly simple diagram or curve, you can say. So it's just a area under this rectangle. So the width, you know, this is 4. So the height will be what?
1/4.
1 by width, that will be 1 by 4. It's very straightforward, right? So the height is 1 by 4, because area has to be 1. So once you get this height, everything is now fairly simple. You can write the expression of PDF. So now I can write this as in mathematical form, that if x is between -2 to 2, this value is 1 by 4, otherwise it is 0. So outside of this range, the PDF is 0. Once you get that one, then it becomes very simple to get all these parameters. The very first thing is what? Expectation of x, mean, right? So this is, I denoted by mu x, I can denote by mx. So I can find the mean by using the formula what? Minus infinity to infinity x fxx dx. Now if you see this, fxx is 0 from minus infinity to minus 2, and it is also 0 from 2 to infinity. So I can break this integration in three components, so three parts. That will be minus infinity to minus 2. This is x, and fxx is 0 there. And from minus 2 to 2, x into fxx is just 1 by 4, because this is throughout the constant from minus 2 to 2. So I can write fxx is 1 by 4 dx, and then from 2 to infinity, again fxx is 0. So once you get this one, what do you get? This value is simply 0. This value is simply 0. You have to just evaluate this thing, and this thing is going to be minus 2 to 2, and 1 by 4 is constant, so I can take it outside. This is dx, then I have 1 by 4 x square. The integration of this x is x square by 2, and it will be from minus 2 to 2. So this will be 1 by 8. When you plug 2, you will get 4 minus, and when you put the lower limit, that is minus 2, the square will be 4. So what do you find here? This and this also got cancelled, and you get the mean value as what? 0. So the mean value is 0. Once I get the mean value, I can find the DC power. So DC power will be just 0 square. So this will be 0. You can say 0 watt. And what the question you are asking is, whenever you are asking the what is the average value, it's fairly simple to answer this question. Instead of doing so much integration and this calculation, I can directly answer this question. This answer is what? Fairly simple. If you go by the intuition, what the intuition is, you are saying that all the values are equiprobable between minus 2 and 2. So if you see this, the negative values have the same probability as the positive values. So if I ask that one, that the random variable which is taking the negative values as well as positive values with the same probability, then on an average, what is the value of this random variable? The answer will be 0. The answer will be 0, because the as many as times you are taking the negative values, you are taking the same number of times the positive values. This is the meaning of uniform random variable. So probability of coming negative value is exactly same as the probability of getting positive value. So this will be what? The mean value has to be 0. So this is the intuition. On an average, what is the value? So this question can be simply answered directly, that it is symmetrical around 0. So this has to be, the mean has to be 0. If I give you some other problem like this one, suppose this is again symmetrical around 0. If you see that one, if I ask the question, so the probability of getting this 2 volt is same as the probability of getting minus 2 volt. So on an average, if you see this one, these all are same. If you go there and if you go there, so all the values are equiprobable. The positive values are same, have the same probability as the negative values. So again, the answer will be, the mean will be 0. If I give you some another diagram like this diagram, like this, suppose, and this value is suppose 2 and this value is 6, this value is 3. Again, if I ask the question, right, sorry, it's not 3, let's say this is 4, and let's say this is 2, right? So again the same thing, the probability of this PDF is symmetrical around 4, then definitely the PDF has the mean has to be now 4. So in this case, the mean will be 4, because now you are saying that one, the values, the probability by which the values are coming between 2 to 4 is exactly same as the probability that the random variable can take value between 4 to 6. So on an average, the answer will be what? Around 4, right? So that will be 4, exactly 4, right? So this is what the mean value is. So this type of question, if you get, you are going to solve this one, you will be in trouble, right? You don't have to solve this integration to get this kind of answer if you have symmetrical PDF. So if you have symmetrical PDF, you don't have to lift a pen and you can directly just answer the question. If you have suppose some weird kind of shape, but suppose it is symmetrical around 4 and the same shape gets repeated. So you can think it's very difficult to solve the integration for this kind of PDF, but you know that when this mean has to be 4, because by intuition I can say these are the same, this is also same on this side, between 4 to 6 and between 2 to 4, this is symmetrical under 4, hence the mean is 4. Are you getting my point? So this kind of answers, the mean can be simply answered if you know that this PDF is symmetrical around some value, and that value is going to be just the mean, right? So this is what the meaning of mean. That intuition is very important, very useful. Now let's find out the mean square value. So to get the mean square value, it is fairly simple. This is what mean square value. Again, you will have what minus infinity to infinity x square fx x dx. So in this case, again, you will break into 3 components, minus infinity to minus 2. This will be x square, but PDF is still 0. Then you have the second part, that is minus 2 to 2. This will be x square fx x dx, and then plus 2 to infinity x square fx x dx. Now again, this fx x is 0 in this region, and in this region it's 1 by 4. So let me write that directly, 1 by 4 there. So this is 1 by 4 and this is 0. So again, this term is 0, this term is 0. You need to evaluate just x square and you can find there. So what is the value there? It's what 1 by 4 minus 2 to 2 x square dx. So this will be 1 by 4 into 1 by 3, because this integration is x cubed by 3, and it will be from minus 2 to 2. You get 1 by 12. When you plug 2, you will get 8, and when you plug minus 2, you will get minus 8. So 8 minus of minus 8 will be 16. So this will be 16 by 12, and the answer will be what? 3 by 4. This is the mean square value. That is what expectation of x square. So you just need to find 2 things. As I said, that one you can find DC value and mean square value, and to get so this is the question that was asked to me, but what I find is DC power is 0. So this is why the AC power will be what? So now if you see this AC power, that will be what? Variance. So this will be sigma x square. This you call as what? Expectation of x minus mu x, the total square, and this should be mean square value. Let me write the mean square value minus DC power. I don't have to solve that integration again, right? So this will be what? 3 by 4 minus 0. So this will be 3 by 4. So in this question particularly, since DC power is 0, the variance and mean square value both are equal, right? Both are equal. Any doubt in this question?
So mean square value is 3, na?
मीन स्क्वायर वैल्यू इज, अभी तक से ये समझ, ये तो है मीन स्क्वायर वैल्यू. व्हाट यू सेड? मीन स्क्वायर वैल्यू इज 4 by 3. It's not 3 by 4. Sorry, this is 4 by 3. This is 4 by 3, right? So this is how you can solve the problem. Let's solve this problem from your side and tell me the answers. Read this question and solve this problem. So now random variable is not x, but random variable is, I'm just change the notations here, right? So random variable is here q sub e, and the numerical value is just small q sub e. Before it was capital X and small x. Now it is capital Q and small q. That's it. The formula has to be in terms of capital Q. You don't want to use this e, then you can just discard this. But I want to say this is quantization error. So this is a problem that is there in PCM, right? There we have derived this formula already. I have derived this formula already there. But again, I'm just asking you to just find out this one from by yourself, so that you'll get the idea of that quantization noise power, right? Yes. कितना मिल रहा है? Mean what is the first of all you have to find out the PDF, right? So delta is a step size. Delta is a step size. Capital delta is a quantizer step size. At the top, building the top. Okay, so then you can measure it. Okay, so simply this rate can be measured of the measuring rate. Okay, so maybe for half the rate, the overall 25 centimeters, so 8.5 outside 2.5 below the PD. Okay, yes. So PDF height will be how much? Consider the rate of this particular. इतना टाइम क्यों लग रहा है? PDF हाइट कितना होगा? So again it's a uniform PDF, no? What is the PDF height?
1 by delta.
1 by delta.
Good. So it's lying between minus delta half to plus delta half. So the area under PDF has to be 1. So the height has to be 1 over the width. So this height will be 1 upon delta to be a valid PDF, right? So this is PDF of quantization error. So you can write E also there if you want. So this axis is now QE. It's not a small x, but it's now quantization error voltage level. So this is PDF. Height you got, that is 1 upon delta. Again, the expectation will be what? You don't have to solve the problem. What is the expectation? Using 0, right? It's symmetrical, you know. So it's symmetrical around the origin, so it has to be 0. So DC power is 0. That is the first thing. Second thing is what? Expectation of, if DC power is 0, then expectation of x square will be variance only. So this is total power and this is AC power. Both will be same because there is no DC power. So both will give you the same answer. So this will be minus infinity to infinity x square, sorry, not x square, but now in this it's a q, no, it's not x, it's a q. So this is QE, this is Q, this is QE, this is QE square, and this is QE. So this will be small QE square, and this will be FQE, QE, DQE, right? Again, you will have the three terms, minus infinity to minus delta half to plus delta half, in which it is the PDF is 1 upon delta, and from delta half to infinity it is what? 0. So you will get three terms, right? So minus infinity to minus delta half QE square into, in this case the PDF is 0 in this region, and from minus delta half to plus delta half, it's just a QE square, and in this region the PDF is constant, which is 1 over delta. 1 over delta is constant, so you can take it outside the integration, and then finally I have integration from delta half to plus infinity. This will be QE square, and this will be 0 in this case. This is DQ. So this value and this value will be simply 0. So this is 0 and this is 0, only this term will exist. What is the answer that you will get? So this is 1 over delta minus delta half to plus delta half QE square DQE. So this will be 1 over delta. This will be Q is Q cube by 3. So I will take this here. This will be Q cube from minus delta half plus delta half. So this will be 1 over 3 delta, and when you plug delta by 2 cube, you get delta cube by 8. When you plug minus delta half, so this will be minus of minus delta cube by 8, right? So this will be 1 over 3 delta, and this will be 2 delta cube by 8. So this will delta square by 12. This is not the first time that we are looking this power, right? We have seen this for power also already. So the this quantization noise power, which is simply mean square value, and in this case the AC power is same. So this is variance. So this will be delta square by 12. So this is called total quantization noise power, and this is what the formula is. So ये formula you have to remember it, right? Because we are going to come across this formula again and again. So this is very important to remember, because in the case of signal to quantization noise ratio for PCM, this formula is something what you require it again and again, right? I hope this is clear. Now let's revisit the problem number 1. Let's revisit problem 1, the question 1, and solve using the result that I got in question number 2, right? So if you see that carefully, the first problem was what? The PDF was varying from -2 to 2, height is 1/4. So here also I am taking this PDF is varying from -2 to 2, and height is 1/4. So this is the question number 1 problem. So this is question number 1 PDF, and if you compare it with the PDF for question number 2, it was minus delta half to plus delta half, height was 1/delta. So the question is find expectation of x and x square and all those things. So if I can relate these two, I can get the answer. Mean is 0. X square is just expectation of x square will be just del square by 12, which is same as the AC power. So if you can find the delta, if you relate this with delta, so what do you find? It's very simple to understand. The width is delta. Here the width is 4. So it means delta is equal to 4. So once you get this delta equal to 4, you can just plug that in this point, that is delta square by 12. And if it is delta square by 12, this will be 4 square by 12, and this is 4/3. So if you have if you remember this diagram and this formula, it will be very helpful to solve this kind of rectangle pulses. This kind of problem with the PDF, which is uniform, right? So DC value is simply 0, because this is starting from minus delta to plus delta and doing the same thing, right? Any doubt in this? See, we don't have to solve many problems by doing integration. It is always what, when you solve 1 or 2 problems, you should be able to generalize. So whenever you get a PDF which is uniform PDF, right? So what is uniform random variable? So there comes what is uniform random variable. So a random variable whose PDF is uniform, whose PDF is uniform, the random variable is called as uniform random variable. So depending on the shape of the PDF, we name the random variable. So it's a uniform random variable, right? Now let's find out that this question. Can you use the same question number 2, right? So I'm not asking to do the integration and solve the problems. I'm asking you to use that question to result, which is very useful, right? So I'm asking you to what, using the result obtained in question number 2. Yes. can you get me the answer? So now this is a random variable whose value is not symmetrical around origin, but it's symmetrical around somewhere else. It's not between what minus delta to plus delta, but you have to think on this situation, right? I know that if you write the integration formula, you get the result, but you will get the result. But I want you to understand this second question usefulness, right? You can generalize it to as many as possible. If this till the random variable is uniform. Yes. What is the mean value? It's very simple, fairly simple, right? The given PDA is what it is now symmetrical around somewhere else, not 0, but so this is again uniform, but its value is between 2 to 6. This is my small x and this is my PDF diagram. First of all, I need to find the height. What is the height? What is the height? What should be the height? Height कितना आएगा?
1/4.
1/4, because the width is 4. The width is 4, so the height will be 1/4. This is the first target that we need to understand, that sometimes PDF is given, but it's not mentioned that what is the height, right? Okay. What is the mean of this? What is the DC value of this? Can you use your intuition and find the answer? You can apply the formula and find the answer. It's not a problem. This is x, fx, x, dx. So you will again have 3 components, minus infinity to 2, 2 to 6, then 6 to infinity. But I am asking you how you will get this answer. Yes. What is the expectation? Yes.
0 है.
0 कैसे आएगा? आप बोल रहे हो आपका रैंडम वेरिएबल 2 to 6 है, तो आपका एवरेज वैल्यू 0 कभी आ सकता है क्या?
नहीं.
सर 4 आएगा.
4 आएगा. 4 आएगा, right? Because you are saying that
4 आएगा 4.
4, no? So the midpoint is 4. So the midpoint is 4. If you find the midpoint of this 2, you will get 2 plus 6 by 2. So this is what the midpoint is. The midpoint is 2 plus 6 by 2, which is 4. So this point is 4, which is midpoint. And if you see this midpoint, why I'm taking this midpoint? Because around 4, PDF is symmetrical. So if I tell you that the values are between 2 and 6 and all the probabilities are same, so it means you are asking me the on an average value. So on an average value will be 4, because it's as much as greater than 4, it is as that much only it is less than also 4, right? So it's like what 4 is some DC value, and as much as you are going above of 4, that much only you are going below. So that's my on an average the value will be 4. So on an average value will be around will be 4 only, because 4 to 6, 4 to 2, as much as you are taking more values than 4, with the same probability we are taking the lower values than 4, right? So the on an average value will be what? You are oscillating around 4, that means, right? So the answer will be 4. You don't have to lift the pen to find the answer. It's just what intuition. So try to understand that intuition. Average, on an average value क्या आएगी? 4 से जितना छोटा है उतना ही बड़ा भी हो रहा है, with the same probability. So answer will be 4. Now what about the total power? Will it change or not? And what about the variance? Will it change or not? Yes. Can anybody just find me what about this in this AC power? and in this AC power. I'm asking you to just tell me AC power. So this width is 4, height is 1 by 4. This width is 4, height is 1 by 4, but it is around 0 and it is around 4, right? So what do you think, the total power will change or AC power will change or both will change? Hmm. First talk about AC power. Will it change or not? What do you think? What do you think? See this problem, what you're doing here. This is a random variable which is x minus mu x, making it a square. So you're taking the random variable, each value, subtracting the mean 4 from this 2, and then finding the expectation, squaring it, then finding the expectation, right? So what is the meaning of this formula? You take each value and subtract the mean value from each value, squaring those values, and then finding the expectation. I hope this is clear. X minus mu x the whole square. You take each value, subtract mean from that value, square it, that will give you random variable, and then find the expectation of that random variable. So you are subtracting the mean value from each one of these values. What did you do here? You take the mean value, subtract it from each one of these values between minus 2 and 2, and square it, and then finding the expectation. So if you subtract the mean value from here as well as here until the width and height are same in this case also and in this case also, so do you think this AC power will change? Yes. Tell me that. If you get this intuition, it will be very helpful. Otherwise, you have to open the integration to solve the problem. What do you think? Yes. Yes, yes. Have you got the idea or not? The formula meaning. Say yes or no. Let's understand this formula. X minus mu x square. Let's first understand this inner part. X minus mu x. X is varying between 2 to 6. Mean is, or mu x is 4. So what you're doing, you are taking each one of these values, let's say 2, then you will take 2.2. I don't know how, there are infinite possible values between 2 and 6. I will take just some samples. Let's take 3, 3.5, 4, 4.5. Let's take 5.2, 5.8, 6. So to get this random variable from this x, what you will do? You will subtract the mean first, square it. Then again you subtract the mean and square it. Then subtract the mean and square it. Then subtract the mean and square it. Subtract the mean and square it. And then you are finding the average of this random variable. So this is random variable. So this is the random variable which is lying between what? It will be from where to where? 2 minus 4, how much it is? Minus 2 square, so that will be 4. And the highest possible value will be, what do you say? Yes, variance will be more when you see this is 0. This will always be positive, right? Are you getting my point? Yes or no? What is this value? This is again 4. What is this value? This will be what? 5.8 minus 4. So that will be less than 4. Less than 4. But it is lying between 0 to 4. Right. So all the values are lying between 0 to 4. If you go here, what you are doing here? You take minus 2, subtract the mean. You take any value, minus 1 suppose, subtract the mean, because mean was 0 in this case. 0 minus 0, 1 minus 2, 2 minus, sorry, 1 minus 0, 2 minus 0 is square. What do you get? Maximum will be 4 at the extreme end, and as you go here, it will be between 0 to 4. Again, it's lying between 0 to 4. You see this? The width is again 0 to 4. So the AC power is something what, no matter what you shift it anywhere, the AC power will not change, right? The AC power will not change because it's a shift invariant, right? It's a what? Shift invariant. You keep your rectangle, this PDF here, or you keep your rectangle PDF somewhere else, but till the width and height are same, the spreadness will not change. And this is what, how you are getting. The spreadness is what? The spreadness is giving you the answer. The spreadness, right? So the same I am arguing over here, that mean square value, sorry, variance will not change. So again, I can compare it with the delta square by 12. So I can call it as a delta, and this will remain same as the previous one. So I will choose this delta square by 12. I will make it what? 4 square by 12. This will be 4 by 3. And now the total power will change because DC power has changed from 0 to something, but AC power remains the same. So the total power will be just addition of this 2 power, which is expectation of x square, which is DC power, and the AC power is just sigma x square. So this will be 4 square plus 4 by 3. So this will be 16 plus 4 by 3, that is 52 by 3. This is what there. So what the intuition I have used here, that variance captures the spreadness. So this is the second intuition I am giving you. First one was the mean, second is the variance, which captures the spreadness, right? It says that one, how much the PDF is spreaded, right? So if you see the spreadness over here is same. If you go back and check your first problem, the spreadness over here is also same. No matter what, I will use the generalized formula. Spreadness, till the spreadness is same, I will get the what? Same del square by 12. So it's just a measure of spreadness. How much you are spreaded, how much your PDF is spreaded. That is what captured by the variance. So this is what one of the very useful what things. What you are saying that when this once you understand this point, it becomes very easy to apply that formula. Anybody is having any doubt, you can ask me. Otherwise, I will move further. Yes. Anybody wants to say something? Tell me. Or you got the problem?
Got it, sir.
Right. So we are asking the question about what, how much, on an average, how much I am far from the mean. See, this is the formula. What? X minus mu x square. You are making it square. So we are saying that one, take random variable, subtract the mean. So you are saying that one, how much you are away from the mean, and then you are doing expectation. So this random variable, so this is the random variable because it's a function of random variable x, so it is going to be another random variable. So expectation of x minus mu x square, what the answer it will give you? Expectation is nothing but on an average. So you are asking the question what? On an average, how much you are away from the mean, right? So this is what, not only on an average, but it's what on and how much you are away from the mean, that is square away from the mean. I should say square away from the mean. Why I'm saying square? Why I'm calling this is average value? Why I'm calling this is average value? Because this is a point at which if I put my needle, the whole structure will not fall on either side. So if you ask me, on an average the value is 4, and you are asking me how much you are away from the origin, the answer will be 0. Just see this point. Expectation of x minus mu x. You take each random variable and subtract mean from each value the random variable takes, and you are asking the question what? How much on an average you are away from the origin. So as much as I am negative away from the mean, that much only I am positive away from the mean. So on an average I will be 0 distance from the origin. That's why 0 distance from the average. That is the meaning of average, right? But if I make it square, then negative away will also become positive away from the mean, right? So this will be better if all the values are positive. So that's why I'm making it square, so that I can so that I can what answer that this question, this spreadness properly. So that's why this will be 0. You can prove it. This value has to be 0. This value has to be 0, because average, the meaning of average is that much only. So if you get 4, and if I ask you that one, how much on an average, how much you are away from the mean value, so I will say जितना नीचे जा रहा हूँ 4 से, उतना ही ऊपर जा रहा हूँ 4 से. जितना मैं नीचे जा रहा हूँ 4 से, उतना ऊपर ही जा रहा हूँ 4 से, because that's why it is I am calling it as an average value, no? So if you ask me on an average how much away from the origin, I will say 0, because नेगेटिव जितना दूर हो आप, इधर के वैल्यू सब नेगेटिव वैल्यूज देंगे. 2 - 4 नेगेटिव, 3 - 4 negative, 3.9 - 4 negative. But after this, if you take the value 4.1 - 4, that will give you positive. So these values greater than 4 are giving you positive distance from the mean, and on this side these are giving you the negative distance from the mean. But since this is average value, so on an average I will be 0 distance from the origin, because as much as I am positive distance away from the origin mean, with the same probability I am with the uh, same I am away in the negative direction as well. But if I make this negative distance positive, then I will ask that, then I may be able to answer this question, the spreadness question, by just what properly, right? So this is the meaning of what. That's why I've written this is square. I've not written what. So this square term is important, right? So this will give you what? Spreadness. It is going to capture the spreadness. So till the spreadness is same, no matter what you will shift your this PDF, you will have the all the time what? Same AC power, right? So this is the meaning to this. Anybody is having any doubt, you may ask please, otherwise I will move further. Yes, say yes or no. So this you can prove. If you want to prove it, you can prove it. This will be always 0, no matter what. It will be always 0. So the question is on an average, right? Okay. Anybody is having any doubt, you may please ask the question, otherwise I will move ahead. Or if you want to say something, then you can ask the question. Yes. Hmm? Yes. समझ में आया क्या? Yes, Nikita.
Yes, sir.
Okay. So variance captures the spreadness, right? And mean is what? On an average value. Okay. So let's come to this point now. You solve this problem by yourself. I will give you 5 minutes and you solve this problem, right? You just solve this problem. Can you see the screen, all of you? You just please take the notebook and pen so that you can do it. So there are 3 questions and you have to answer this question. Now x is just y is just a function of x, which is cos x. So sometimes people they just give you like this, like this. So we have to understand this is just a function of x. So I need to write this as a g of x. If you go here, it will become complicated. You just think like this is a function of x, which is cos x in this case. Find the answer. And let me just take this as a pi by 2. It's not pi, let's take pi by 2. Let's change something different, right? So it is 0 to pi by 2. Solve this problem. This way you will execute this particular modular execute. So that way so I am asking you to find only the mean value, not mean square and all those things, but just find the mean value. You can find mean square and all those things also, but you just find mean value. It is just a 4 to 5 minutes question only, right? It's not more than that. Last problem I just modified it. It's not 0 to pi, it's 0 to pi by 2. It's 5 minutes and solve it, right? You can parallelly complete your work and submit. And the way it should be, what as it is in format, okay, in the proper way, as it is. Have I started recording or not? Let me check this.
So recording is on.
Okay. I got mute. I don't know how. Have I muted myself or you are following me? No. So you just have 5 minutes solve that problem, right? Anybody got the answer? Part A,
0.
0. Part
Sir,
B, okay.
5.
Part B is what?
5.
पाई कैसे मिल रहा है? No. Check it one more time. Part B is not pi. Go it slowly, right? Don't go very fast. Try to solve it, right? Go slowly, but
So, sir, B is 0.
yes, what is the answer you are getting? Hey, this
0 second.
second is 0. What is third one?
2 upon pi.
0 by pi.
Pi by
How much? Repeat it. 2 upon pi.
Yes, sir.
Okay. Just let me write the problem that it's fairly simple, right? I will just give you that idea. How can you make the steps simpler and generalize it for the formula, right? So first of all, I need to find the again PDF. So for this, I can write my PDF expression. So this will be what this fx x will be from minus pi to pi. So the width will be 2 pi. So this will be 2 pi if x is lying between minus pi to pi, and otherwise it will be 0, right? For this PDF I can write as again 1 upon 2 pi. The width is same, but it is lying between 0 to 2 pi, and it is 0 otherwise. And this is what fx x. I'm writing very small, right? I don't know you are able to see it not, but this will be 2 upon pi from x from 0 to pi by 2, and this will be 0 otherwise. So this is the very first step that I need to follow, and that I did. Now let's apply the formula. Since this is g of x, it is nothing but a function of x, so I will write g of x. So the integration has to be minus infinity to plus infinity cos x and fxx dx. So again I will have three integration term, minus infinity to minus pi to pi, and then pi to infinity. So the two first and last term will be 0 because fxx is 0 in that region. So I will get only what 0 to minus pi to pi case, minus pi to pi, and this will be simply cos x dx. So this will be sin x ranging from minus pi to pi. So sin pi minus of minus sin pi. So sin of minus pi is just minus sin pi. So this will be plus sin pi, because sin of minus pi is minus sin pi, and this is lower limit, so minus will be there. So minus and minus got cancelled. It will get sin pi. Sin pi is 0. This is also 0. So the answer will be 0. Very straightforward. No problem in this. Let's solve this second problem. In this case, this will be minus infinity to infinity. Again, I will start with the same thing because random variable is same, but the range is different. That is only difference in this. So this will be from 0 to 2 pi, and this again same thing will be there. So what I will find here, in all this step, I will have only this step to be evaluated. If you see this thing one by one, so this will be from 0 to 2 pi. So this will be sine 2 pi, and this will be sine 0. Sine 0 is 0, we know this. So sine 2 pi is 0, sine 0 is also 0. Okay, I forgot it, right? I have to write this fxx, no? Fxx is 1 upon 2 pi. I just forgot it to write 1 upon 2 pi over here. So 1 upon 2 pi will be there before this integration. So 1 upon 2 pi will be there. So this will be 1 upon 2 pi. I forgot to write that, right? Okay. So this is what 0. So we'll get 0. It's not the only integration of cos x, but just integration of cos x into fxx, which is constant in that region. So just move it slightly little bit down, and now let's solve this. So this will be minus infinity to infinity, everything same. Why I'm doing this one? Because I'm going to find it again and again, right? So that I can generalize the formula every time I get these things. This will be now 0 to pi by 2, and this will be 2 by pi, right? So this will be 2 by pi. This PDF is 2 by pi in the range 0 to pi by 2, and otherwise it is 0 again. So this will be cos x dx. So this will be 2 by pi, and the integration of cos will be sin x, and it will be 0 to pi by 2. You will get sine over pi by 2 minus sine of 0. Sine of 0 is okay. Again I did mistake over there. If I'm forgetting to include this 2 over pi again and again. So This will be 2 over pi. This is 0 and sine pi by 2, it's fairly simple, which is 1. So this is 1 into 2 by pi. The answer will be 2 by pi. Right? Is this clear? So this is what the cos x is. But what do you find till the range is 0 to 2 pi? Till the range is 2 pi range, means you are occupying all the values, right? See this point here. Means you will have always a positive area and negative area in case of cos x. So you are finding the area only, right? So area under this cos x will always be 0 when the range is 2 pi or in multiple of 2 pi, right? So this will always be 0. But when you get range is pi by 2, it get non-zero value. What happens if you get 0 to pi? The answer will be also 0, because the area between 0 to pi, just you can think on the situation, 0 to pi will also be 0. You can find that answer there, but this is just a simple exercise that I have given here. But this is what we have to think on this trigonometric things, right? Now let's come to the original problem that will be asked in the exam, whether it is unit test, whether it is university exam. It comes for around 8 marks, 6 to 8 marks, right? Same the given random process, but they ask different question on this. So I've just taken A and B for the time being. There are so many problems they can ask, A, B, C, D, E, F, G, H, like kind of thing. But ultimately they have this same random process, and they ask the question on this. So just concentrate on this. This is a random process. First of all, you tell me, do you accept this is a random process or not? Yes, Ayush. Is it a random process or not? Yes.
Yes, sir, it is a random process.
It's a random process, right? So if it is a random process, then it has to include time in it and the random variable in it. So it's included. It has included the time and the random variable, which is capital theta. This is called capital theta. This notation, no, we call it capital theta. So we always say what we will write random variable as capital later. So you may get confused that A is capital. So should I take this as a random variable or not? It will be given in the problem, right? So what the problem is given here is only theta is random variable, not A is random variable. It might happen you may have random process in which more than one random variables are there. But since we are talking only one random variable, so there will be one random variable. But in the question, it might happen that A is also random. A is not random variable in this case. So theta is what? So this is theta, and this capital theta, capital letter theta, is uniform random variable. Again, uniform random variable over. So this will be supposed from 0 to 2 pi, or you can take minus pi to pi, what you want. You can take anything. So let me take minus pi to pi. And A is constant. A is not random variable. So I'm writing this purposely. A is constant. But until and unless they will tell only the theta is random variable, then you can assume A is constant, right? Or if you get confused, you just write a small a there, right? Because we don't want to mix the notations here. Okay. Anyway, it's written constant, so it's not a random variable. So it's only only random variable. And think like this. Can I call this function as function of random variable, which is g of theta? Yes or no? Because this is going to the first state that we have to think on. Can I call this as a function of theta, g of theta?
Yes.
Yes. So still I can use the same formula that I have learned in random variable, right? The first page that I have shown it to you, this formula, right? So I can still use this formula. Okay, that's fine. Whenever you do statistical analysis, you just assume t is constant. This was the question asked in the class also, I think. Somebody has asked, I don't know this in T7 or T8 they asked, but they asked the question that whenever you deal with this kind of statistical average, you can assume t as a constant. It is not a random variable. Theta is a random variable, but when you do time average, you have to think theta as constant, but t as what? Variable. So we will go back and forth between constant and variable kind of thing. But here we are assuming theta is only random variable, t is not random variable. So it's a function of only one random variable. So we are writing as a function of one random variable. So t will treat this as a constant whenever I get. Is this clear? Say yes or no. Is this clear?
Yes, sir.
Okay. So first thing will come first. So let's talk about expectation of xt. So xt is a random process in which theta is a random variable, right? There is so many application of this. I will explain if time permits me that where you can get this kind of random process, right? Okay. So for the timing, just assume this is a random process. Where the actual application I will explain later on. So let's think like this. So this is first thing is A, part A. I'm going to solve part A, but for that I need to find the PDF, right? So PDF. Let's draw PDF. So theta is a random variable. Let's draw this time. So theta is a random variable. Just see it carefully because this is very important. So this is small theta. So small theta is this one. And this is PDF of random variable, which is capital theta. So capital theta, it's written like this. One big circle and inside this just a sine wave. And this is small theta. So the notation is very much, it should be according to the notation, right? Sometimes people in book they don't differentiate capital and small. They write small theta, but they say this is random variable. But whenever you get this question, you frame it in your form so that it will you don't get confusion. It's between minus pi to pi. So the height again it will be 1 upon 2 pi. Mathematically you can write. So this is f theta theta. This will be uniform, so it will be 1 upon 2 pi in the range when theta lies between pi to minus pi. Otherwise it will be 0. Straightforward. I got my PDF. The first step always. Let's find the expectation of x of t. So solve the first part, that is this is a solution, part A. So we are saying that this is expectation of xt. Now we are finding the expectation of xt, which is random process, right? Don't open the integration till you can write the steps, right? So first go in this only. Don't open the integration first, right? I will explain why. Now just think this one. X of t, I've written a cos 2 pi fct plus theta, and I'm saying this is a function of theta. So this is g theta. So for me, this is g theta. So this is what expectation of g theta, where g theta is just a cos omega ct and a cos 2 pi fct plus capital theta. Let's write down the formula now, right? So let me write this. Now I can write the formula. It should be from minus infinity to plus infinity. It should be a cos g of small theta will be 2 pi fct plus small theta, and then f theta theta d theta. Any doubt in this step? Any doubt in this step? बोलिए है ना, कुछ बोलेंगे तो समझ में आएगा जल्दी जल्दी मेरे को भी. Any doubt in this step?
No, sir.
Okay.
No.
Now again we will have three integration term. First and last term will be 0. Only the integration from minus pi to pi will exist. It may be, it may not, it may be 0 also, but let's say only this I need to evaluate. That is a point that I'm saying. So this is 2 pi fct plus small theta, and f theta in this region is 1 upon 2 pi. So this is 1 upon 2 pi d theta. Now see this carefully. This is going to be 1 upon 2 pi constant. So let me write a also constant. So it will be outside of the integration, minus pi to pi, and this will be simply cos. I'm going very slowly, right? 2 pi fct plus theta d theta. Now this is the integration with respect to this is the integration which is with respect to theta. So t is just assume as constant for integration, because it's not with respect to time, but it is with respect to theta, right? So it is with respect to theta. So these values are with respect to theta. So t is just going to be constant. So we know that when this integration will be what? What is the integration? Sine 2 pi fct plus theta. That's it. The limit will be minus pi to pi, right? I need to plug the pi there. So I will get what limits. First I will put upper limit. So this will be sine 2 pi fct plus pi minus sine 2 pi fct minus pi. This answer we already know, it should be 0, right? So this is a by 2 pi sine. Let me rearrange this term so that we will get this term in terms of pi plus angle. So this is pi plus 2 pi fct minus sine, and when you take pi minus, so this will be minus of that quantity. So this will be minus pi minus 2 pi fct, and sine of minus theta is sine minus sine theta. So this will be a by 2 pi. So this will be sine pi plus 2 pi fct minus sine of minus will be minus, and minus is already there, so this becomes plus. So this will be sine of pi minus 2 pi fct. Now sine pi plus theta, what is the value? Sine pi plus theta, and psi pi plus minus theta, let me write, because this is also there. So what will be there? Sin pi plus theta क्या होता है? What is sin pi plus theta?
Sin theta.
Minus sin theta.
Minus sin theta, and pi minus theta?
Sin theta.
Sin theta. So minus, if pi minus theta is plus, plus pi plus theta will be minus sin theta. ये आना चाहिए. Without that you will not able to solve this problem, right? So go and check your trigonometric identities. I am not able to explain this here now because I don't have that much time here. I've explained it in analog communication practical. So this is what sine pi plus theta will be minus sine of this 2 pi fct, right? Don't get confused with theta. It just like, let me write z over here. So this will be, so z is 2 pi fct over here. So this will be 2 pi fct and plus sine 2 pi fct. Once you get this one, this and this got cancelled, and the answer what you get is expectation of, let me write, expectation of xt will be 0, and this is what the expectation is, right? So this is statistical mean is 0. We say the statistical mean of xt is 0, right? statistical mean is 0. So without, if you don't know at all what is this random process is, how to define random process, what is random process, if you don't know that also, no, do I have used anything related to random process here? Have I said anything with the random process to find this expectation of xt? I have just borrowed this formula from random variable. If you understand that this t and this all things are just constant, you can just assume this is g of theta. If you don't know also, know what is random process, what is not random process, if you don't know that also, no, you can solve this problem if you know the concept of random variable. So random variable, if you know, you can write this as a g of theta, then everything is just like a random variable only. So this is something I'm saying this is a random process because this time is there. If I write something else over here, instead of t, if I write this as a 4 or 5, then also it's a random variable, right? So it does not, I'm saying that one just it is just a what matter of random variable. If you think like this, right? At least for this part A. Let's see for part B. Now let's solve this part B. Part B is what asking about expectation of xt1 into xt2. So this is again a problem. This is given. If you think this was what is xt1, if you don't know also, no, this is a random variable, then also it is okay for me. Random process. If you don't know what is the random process, then also I can solve this problem. Why I'm saying that? The interpretation will come after learning random process, but to solve this problem, you don't have to understand what the random process is, right? But the interpretation of the result, what we will get, it will surely depends on the concept of random process, that what is random process is, right? So when you fix time t equal to t1, you get a random variable. Yes or no? Say yes or no. Yes. If you fix xt at t equal to t1, you get a random variable. Yes or no?
Yes. Yes, sir.
This is random
Yes, sir.
variable. When you fix t equal to t2, you will get another random variable. So this is random variable. At t1, you sample the process, you get one random variable. At t equal to t2, you sample the process and you get another random variable. But the point is, this interpretation are going to come after only you know the random process, what the random process is, right? But this is fairly simple. I know this is random variable, right? Because I know what is random process is. But the solution does not depend on whether you know it, whether you know random process or not. So again, you are going to get the same, get the expectation like this, right? So he's asking me about what? First find xt1. So let's find xt1. Let's replace t with t1. I get a cos 2 pi fc. T replaced with t1 will be t1 plus theta. Similarly, this will be xt2 will be a cos 2 pi fc2 t2 plus capital theta. I get two random variables. Again, let's go and multiply this two because it is asking me to multiply these two things. So let's multiply this two. xt1 into xt2. Let's find the product first, right? If you multiply this, you will get what? A cos 2 pi fc t1 plus theta into A cos 2 pi fc t2 plus capital theta. When you multiply these two, what you will get? You need to understand this is going to be cos c into cos d formula. So you will get two terms. So can you tell me what is the formula for cos c into cos d? So this you need to understand, right? It is not it is just a trigonometric identity that you need to understand. What is the formula for this? How you write this in two terms, cos c plus d and cos c minus d? What is the formula there? Yes, Mary, you don't know this? बोलो बोलो, जल्दी बोलो तो जल्दी करेंगे अपन, खत्म होगा जल्दी. 10 मिनट बच गए, 15 मिनट बच गए बस, बोलिए.
cos a minus b
प्लस कॉस ए प्लस बी।
अरे भाई ये ए बी नहीं है, यहाँ पे सी डी लिखा है मैंने।
सर ए के मतलब ए की जगह सी और बी की जगह डी।
Okay, so you are saying this is let me write cos d minus c and plus cos c d plus c or c plus d, whatever it is. बस इतना ही होता है,
डिवाइड बाय 2 सर।
डिवाइड बाय 2। अब ये फॉर्मूला जिसको नहीं आएगा he will not be able to solve this problem, right? So you think how can you remember this formula? Otherwise you cannot solve this problem, right? So let's now get this product. xt1 into xt2 will be, this a is there, this a is there, so this will be a square, and this by 2 will be there, so this will be a square by 2, and then simply just assume this as a c and this as d. So d minus c will be 2 pi fc t2 minus t1, and when you subtract random variable from the same random variable, you will get 0, so this will be 0. Sorry, I have to write cos also, so this will be inside cos, so this will be cos plus next part will come, which will be cos 2 pi fc t1 plus t2 plus capital theta, and the whole thing is right. Okay, now we need to find the expectation of this quantity, so let me write that expectation. Now the actual problem will start from here. This will be xt1 times xt2. So this is asking me to find out the expectation of a square by 2 and the whole thing. This is cos 2 pi fc t2 minus t1 plus cos 2 pi fc t1 plus t2. Sorry, this will be plus 2 theta, no, this will be not theta, it will be 2 theta, because this is theta plus theta will be 2 theta, right? Here is the theta, here is the theta, so you will get 2 theta, so this will be 2 theta, so this will be 2 theta, and this whole thing will be there. And just see this now, what is this, is a square by 2 is constant, so I will take it outside of the expectation. Now you get expectation of cos 2 pi fc t2 minus t1 plus cos 2 pi fc t1 plus t2 plus 2 theta. This is capital theta, sorry, this is capital theta, right? And this one will be there. Now what I'm saying is expectation of sum, this is sum, right? Sum of these two things, one thing is this one thing is this one. Expectation of this two thing will be sum of the expectation of these things, so I will use that one. So this is the linearity property, right? So expectation is a linear operator, expectation is a linear operator, so expectation of sum will be sum of expectation. It's very straightforward. So I will have two terms, one is the expectation of cos 2 pi fc t2 minus t1, and I will get another term which is will be expectation of cos 2 pi fc t1 plus t2, so this will be big bracket, and this is 2 theta. I get two terms, so this will be whole multiplied with a square by 2. Now from there you need to think something. Okay, what is this? Is it a constant or random variable? Can anybody tell me? Is it a constant or random variable? Yes?
Constant.
Constant, right? Till I am doing what statistical averages, nothing to worry about this time. So this is constant. So I need to understand, right? This is constant, not a random variable. But this is a function of random variable, so it will be random variable. So this is g theta theta, where I need to use this f theta theta. I can solve it like I have just solved the mean here. I've solved this, this thing again. I have to repeat it again. So the same thing I need to repeat it for this also. This is constant. So I don't know about this one, but what is this? Expectation of any constant value is what? Expectation of any constant will be what? कोई बोल सकता है? Can anybody tell me? Expectation of any constant is what? Okay, solve this problem. This is a constant, no? So you can just think like a random variable x, or let's say it is let's say x, and its output is always constant. So it is taking sample space, each outcome from the sample space, mapping it to constant value. So you are like a subroutine, and no matter what the input you are giving, which outcome you are giving at the input of this subroutine, it is giving you only one number, only constant value. So I am asking you that one, if random variable is taking one value, what is the average value of this then? Yes? Yes. Yes.
That constant only.
That constant only, right? So if any random variable which is taking always a one value only, if the constant value is always giving you one value, so the on an average the value will be same, no? This is the intuition. So that will give you constant only. So this is what by intuition. You don't have to open this integration. What I'm saying is you don't have to open the integration. If you want to open it, open it. You will get what? Minus infinity to infinity constant times what? F theta theta d theta. So constant will come out from the integration, and this will be minus infinity to infinity f theta theta d theta. And what we said there, area under PDF must be 1. So this quantity will be what? 1. So what do you get? Constant. So if you apply the formula also, no, then you will get this constant. So unnecessarily applying this formula, it is not of any use, right? Because I know that one, what is the meaning of average? If any random variable is always taking one value, and if you are asking me on an average, what is the value of this random variable, I will say that is the same constant value, right? So this part, let me write this as part as 1, and let me write this part as 2, right? So this is for part 1. So part 1 is itself this one. So expectation of this quantity will be this quantity itself. So let me go and write that. So that's why I will get a square by 2, and this constant itself. This is what? Cos 2 pi fc t2 minus t1, right? Now let's come to the second part. So this is the first part. What is the second part? You will get f theta theta. Let me write it now. You can again use the formula and can find the answer, or you can argue it, right? What is the what is f theta theta? If you remember, this is 1 upon 2 pi. It's varying from minus pi to theta is varying from minus pi to pi, and otherwise it is 0. This is the same question that I am asking here. It's a theta, and here if you see, this is g theta, and g theta in this case it's a theta. But now in this case, what is it? It's a 2 theta. So आप theta को 2 से multiply कर लेंगे तो आपको वही मिलने वाला है, right? What the output of this? Can you predict the output of this? Because the theta is varying from minus pi to pi and it's uniform. So you are saying this 2 theta is going to be vary from minus 2 pi to 2 pi. If theta is varying from minus pi to pi, then 2 theta will vary from where to where? Minus 2 pi to 2 pi. Again, you will get the integer number of cycles only. Yes or no? Yes or no? Yes or no?
Yes.
So this output should be what? What should be this output?
0.
0, because no matter what, if it will be 1.5, then I have to do that one, but it's just 2 multiplied this one. So minus pi से pi vary करिए आप, या minus 2 pi से 2 pi vary करिए, you are getting this whole number of cycles, integer number of cycles. And or you do what, something like what, let's say pi by minus pi by 2 to minus pi by 2 plus 2 pi, then also you are having the same range 2 pi. Till the range is 2 pi, you can always make it 0. You can always think this as a 0. The average value will be always be 0 if it is uniform PDF. So minus pi to pi, theta is minus pi to pi. So 2 theta will be minus 2 pi to 2 pi. This is the case, right? So till the range is 2 pi or multiple of 2 pi. So let me write this, range is 2 pi or 2n pi. This will always be 0. Just like this one, minus pi by 2 to minus pi by 2 plus 2 pi, the range is 2 pi. Minus pi to pi, range is 2 pi. No matter what, the range is 2 pi or 2n pi or integer of 2 pi, this always gives you 0. If you don't accept my argument, you can do the open the integration, you can solve that one. If you want to open that integration, you have to solve this problem again, that is part 2. So part 2 is fairly simple. So part 2, you need to use this expectation of this one. So this will be what? You need to open that integration, minus infinity to infinity, do the same thing and find the answer. So fc t1 plus t2, t1 plus t2 is just constant for me. I don't have to bother about this t1 plus t2. I can write this as a t3, whatever I want to write. This is 2 theta, small 2 theta, and then f theta, theta, f theta, theta, d theta. You solve this problem, you'll get 0, right? I'm not doing this one, you do it if you want to. If you don't accept my argument, you do it, right? So intuition will give you right. Intuition will give you the what facility to don't have to open the integration. We always worry about integration. So till the time you don't want integration, don't open that. Once you open it, you are going to do this kind of things, and you know that how difficult it is. We don't know differentiation, how to do the integration, right? So we should avoid it. We are not mathematicians, we are engineers. So this will be 0. So this term will be 0. This is my part 2, right? So this is my part 2. So what I get this expectation of x t1 times x t2, this is equal to a square by 2 cos 2 pi fc and t2 minus t1. Now the interpretation is very important. What the interpretation is now, right? So this is the result that I got. Okay, let me ask the first question. You just see this point. xt1 is a random process. So let me write that. Random variable. xt1 a random variable when you observe or sample the process. Observe this interpretation requires the random process, right? Sample the random process at t equal to t1. What is xt2? xt2 is again a random variable, or you can write another random variable when we observe the random process at t equal to t2. So these are two random variables. So let's just try to see this process, right? Let's draw some sample functions. Let me draw like this. I don't know what I'm drawing, but let's draw 2 or 3 sample functions. There may be infinite random sample functions. I'm just drawing 2 or 3. So I've just drawn 2 or 3 random variables. Let me different color. So this is ensemble of random process. I'm going to call it x1t due to outcome 1, x2t due to outcome 2, and x3t due to outcome 3. So let me write just any sample function. So this is, let's say this is x3t only, right? Let's sample the process. When you sample the process, what do you get? So when you sample the process at t1 and at t2, right? Let me use some different color. At t2, this two random variables I am sampling. So this is what x t1 and this is my x t2, two random variables, right? So this time is t1, so this time is t1 and this time is t2. What I'm saying is this: the autocorrelation, this is called autocorrelation. Let me write this as what? This is called as autocorrelation, which is a function of two random variable and depending on two times, t1 and t2. So this is called autocorrelation. Correlation means what? What is correlation? Correlation is nothing but there are two random variables and you want to find the relation between these two random variables. So this is called correlation. And why this auto comes? Auto is something what? When you sample the same random process to get the two random variable, you call it auto. You may have cross correlation also. Cross correlation is what? One random variable from one random process and one random variable from another random process. So that you call cross correlation. So here we are talking about from the same random process I am getting two random variable, so I am calling it auto, and we are finding the correlation between these two. That is nothing but the product of these two and then find the expectation. So this name is given to this is what? Autocorrelation, right? Anybody is having a doubt in this? So it is in general function of t1 and t2. Now you just see this one, what this formula is. It's a square by 2 cos 2 pi fc t2 minus t1. So is it depending on the absolute time? Just answer me. Is it depending on the absolute time? Is it depending on the absolute time? Yes. The question is it? I will take just 2 or 5 more minutes, then we will wind up, right? Is it depending on absolute time? Answer this question. Is it dependent on absolute time? Yes. Can anybody tell me? Is it dependent on T1 or T2 separately? Yes.
No.
No. It is depending on what? The time difference between the random variable which you have taken. So if I choose this T1, T2, or let me choose two more random variable. Suppose at this one and at this one. Right. So this is now, let's say this is T3 and T4. So this is my random variable x t3 and this is my random variable x t4. Just see this one. Till the separation between two random variable is same. Till the separation between these two random variables are same. So this is del t and this is del t. So this is 1 and 2 and this is 3 and 4. Till this del t is same, then autocorrelation T1 comma T2 will be same as Rx T3 comma T4. So if you choose two random variables which are separated by same time difference, for those two random variables, the autocorrelation similarities between these two random variables will come out to be same. And that is only function of time difference, whether it is t2 minus t1 or will be it is just a function of t4 minus t3. So let me call this as a tau. So this will be tau. So this is, let's say this is tau. So that is only function of what? The time difference. It does not depend on the absolute time. So it does not matter where you have started your random process. For autocorrelation, if the autocorrelation, see, for this random process, right? For this random process, it might happen, may depend on the absolute time also. But for the given example, it is not depending on the absolute time. If you choose two random variables, if the separation, if you keep same, you get always same autocorrelation for this random process. It is means that this is special type of random process in which the autocorrelation is only function of the time difference. It is only function of time difference. It does not depend on the absolute time. But there are also random process in which this autocorrelation also depends on what? The absolute time. It will depend on t1, t2, and like this, right? So this kind of random process is called this is called as what? Stationarity in autocorrelation. This is called what? Stationary in autocorrelation. Now let's just take t1 and t2, right? This is very interesting one. Now let t1 equal to t2. When you say t1 equal to t2, you are talking about the same random variable. This is same. So let me write, you are talking about a random variable at any time t. So what this formula leads to? xt1 into xt2 will be x square t. What we call it? What we call it? What we call it? What this formula is? Mean square value, mean square value. So let me call it total power. So in general, total power of random process depends on time. But what about this given problem? This will be a square by 2 cos 2 pi fc. T1 and T2 are same. So this will be 0. Cos 0 will be what? Cos 0 is 1. So this will give you a square by 2. Means this is a random process. No matter at what time you look, you take random variable, all the random variables have the same power. Is this clear? So xt1 power is same as xt2 power, is same as xt3 power, same as the xt4 power. Are you getting my point? Because it is not depending on time. It is independent of time. So no matter at what time you look the random process, the power of random process is constant, and that power is a square by 2. टाइम एवरेज पावर साइन का कितना आता है, कॉस का कितना आता है? ए स्क्वायर बाई 2 ही आता है ना, जब आप इसको टाइम एवरेज पावर निकालते हो. इसका कोई पूछे आपको पावर क्या है? टाइम एवरेज पावर, नॉट स्टैटिस्टिकल पावर. व्हाट डू यू से? एम्पलीट्यूड इज ए, आरएमएस वैल्यू विल बी a square, RMS value will be a by root 2, so the power will be a square by 2. So you will see that one. This is the example where the time average power is equal to the statistical average power, right? So I will come to this point again next time when we will meet. So in the class I will explain this one, but is this point clear? So mean square value is nothing but autocorrelation when T1 is equal to T2. So mean square value is a special case of autocorrelation where T1 and T2 both are same. Is this point understood? Is this point understood? So यहाँ पे I have asked actually 3 questions. One is the autocorrelation. We call it autocorrelation. It is in general function of T1 and T2, but in our case it is a function of difference T1 minus T2 in this example, but in general it's a function of T1 and T2 separately. So it depends on T1 and T2 separately. But in our example, it came out to be difference of time. And C is what? Expectation of x squared t. See this. This is a special case of B. Right? I hope this is clear. किसी को डाउट है इस पे? Anybody having any doubt? So the answer is here no. Right? It depends only the time difference. It depends only the time difference. So किस time पे आपने random variable उठाया है? It does not depend, but it depends on only the time difference. Right? In this example. So I can write this Rx autocorrelation as what? T2 minus T1. So I can write this as Rx tau. Tau is nothing but T2 minus T1. So tau बढ़ाओगे, its value will vary. And how it is varying? You can check it. Different, you take the different difference, you get the different autocorrelation value. Tau will be 0, it will give you power. Tau will be 1, it will give you some different number. Tau will be 2, it will give you different number. But it will only function of time difference. Right? So this is what the whole thing is. So I will stop the recording now.